is how we deal with, random times when I'm working on stuff and things, and we're advertising this open science idea, and there's no reason not to record a bunch of stuff like this. It's just that we don't really want the formality of a full live stream, if that makes sense.
Mm-hmm.
So I'm thinking we might record and then just release them, when they're finished, type thing. Like just upload and release, and people who are interested can go listen to them. Some of them may be silent. It's like a silent movie, a silent science. Okay, where were we here? This was, oh, wow, we're back to this again. Function repository sources. Oh, look at that. That's gotten a lot shorter. Now, I don't even know whether the things that are there are actually needed anymore. Do you know whether those things that are listed there?
I mean, the functions of mine that are there are not needed anymore, but I can't speak for the others.
Okay, well, let's actually, hold on one second. I'm going to ask if Devin and Sushma can very briefly join us. Okay. Excuse me. Physics. Code development. Okay, those are published. Like generational multi-way system, is that published now?
Yeah. Yeah, as I say, all of my functions don't need to be there.
Okay, so should they just be moved? So which ones? Find critical pairs, Knuth-Bendix one.
Yeah, all of those up to generational multi-way system, canonical critical pairs.
Okay, those should go to published, correct?
They may already be there. I don't know.
Apparently they weren't.
Okay. Total causal invariant Q, canonical critical pairs, and all of the multi-way system functions.
Hello?
Hey, we were just rearranging the function repository sources, and we realized that there's some functions that are there that we think are published. I mean, Jonathan is saying they're published, and I'm just asking about the top level because we're about to start adding new functions there.
Okay, if it is published, it should be in the published folder. So the total causal invariant Q, yeah, it is published. Yes, I think I missed that.
Okay, no problem.
It's possible it's an old version, in which case we should.
I can make sure that it is not it's the up-to-date version.
Okay, lattice graph was never done. Okay, so this multi-way evolution plot and so on, are these still real things, or are they?
Those are all published. As I say, I think all of the ones that
I'm going to put those in archives because
yeah.
I'm worried that this is the wrong version of those.
Yep.
Ooh, keep both. Okay, so it's already something there.
There are lots of archived versions of that code.
Okay, ordered graph model plot. Is that a thing?
Published, yeah.
Okay. Okay, random Wolfram model. That's published too.
That is published, yeah. The rest of the two are not published.
Okay. Okay, so canonical critical pairs and canonical critical pairs is published.
Yep.
Okay, can we talk about the workflow? So we're just about to create a new function here, and I would like, maybe Jan can be the finisher for this function, if that makes sense.
Yeah.
Okay.
Yep.
And by the way, we probably should put out, this is another thing when and I'm sort of waiting for Devin to show up here because I think he's the one who would really be doing this. We should tweet when we put a new function in the function repository for the, in fact, I'm going to make that comment to people that that's a thing we should do.
Okay.
Something to remember. That's the new function to WFR or something to WDR. What is the status of getting the my data?
Yeah, I know what you're asking about. So we did ask with the data repository team, and Ed was saying like some of those files are bigger than 50 MB, which is a problem for the data.
Okay, well, but that's not a reason to do nothing, right?
Okay.
We should
Yeah.
upload all the ones that are not,
Yeah.
and then the ones that are bigger, we'll find a different solution for.
Okay.
And that solution could be, that the data repository simply points to something on, in the cloud or on the CDN that is that file. Get what I'm saying?
Yeah, I'll ask them.
I mean, some of them are huge, like 7 gigabytes, right?
Yeah. Yeah.
And I think, the most relevant, let me just show you. Did Devin come or not?
I don't see him yet.
Okay. I've got these files here, and there's just a bunch of things here that I actually, with the new data repository stuff, I could probably just do this. Because I keep on using these. These are really quite useful. These are rule enumeration things. Right, so we've got all of these, and I kind of think, let's look at them for a second here.
Do you know how you want to document it? I think if we have some idea of how we want to document it, we could just, like John could do it very easily.
Right, so we've got 136 megabyte one here, but I think that what we should do for I think it's let me just let's see. I haven't really used this before, but this is okay. So let's see, canonical Wolfram models with specified signatures. Let's see, enumerations. Okay, so let's store this in, instead of function repository, I'm going to put this in code development, and then I'm going to say, oh, look, data repository sources. What do you know? So this is rule enumeration 01. Okay, so then this here would be okay, so I'm not even sure. We might have a default. Okay, so does it need a name there? Additional data elements, optional. So what I'm thinking here, if we can do it, is that we literally just say, like, let me take the example of this one here, 1111, okay? That we literally say 11, let's see, it's the rule signature. So it's 11 arrow 11, like that. See what I'm saying? Equals, and then it would be file of whatever that thing is there. I think I can do that with option, can't I? That's not well put in there, but you get what I'm saying.
Yeah, I mean, I think I would use the cloud file rather than.
Well, is there a cloud file? I don't even know whether. Okay.
Yeah.
Okay. Well, okay. If you can tell me where the cloud file is, that's fine. Is there a cloud file of the 7 GB one, or is that one omitted in the cloud version?
No, there was no problem uploading them to cloud file. I don't.
Okay. Well, then in that case, the data repository team we might just want to proxy through to the cloud. That is to point to the cloud here. I don't know. I think for all of them except the 7 GB one, we can just put them in here.
Okay.
Right? I mean, the 7 GB one, look, I mean, there's an infinite number of ones that are omitted because they're too big anyway. We just never computed them.
Yeah.
And arguably, you know, now that the project is out, we should encourage people to compute more of these. I mean, it really wouldn't be, it's actually a reasonable idea. I mean, if people are asking, you know, what can they do that's useful, that uses computation, this is a reasonable thing. Okay, anyway, so that will be the goal, right? Just take all of these files and have them work like that.
Okay. Okay. I see. Never mind. I mean, I've never done a data repository thing. I think the name would just be the title that you gave, right?
This thing here.
Yeah. No.
Oh,
yes.
yeah. That's how that works.
Okay.
Yes. Canonical enumerations of canonical Wolfram model rules with particular signatures. I don't think there are any particular additional details to give. I mean, and here it's like we just get the results. I mean, it's I mean, I assume that if we do this here, we just do that, and then down here we can say, let's see if it works. That's not a good sign. I don't understand why that failed. But okay, let's let Jan try and take this away and try and create this, okay?
Okay. Yep.
If you can do that. Did Devin join us?
Yes, I'm here.
Okay, so that's probably for you to deal with. But
Yeah.
let's see if Jan can turn this around like today, tomorrow-ish.
Yeah.
Okay.
Okay.
Okay, thanks. All right, that's that. Okay, so now we're going to create another one, causal connection graph. So I just want to understand the workflow. I mean, that Devin is going to be in charge here. Jonathan and I are going to make a rough cut of this, and hopefully Jan is going to finish it.
Okay.
Okay, so now let me make a comment about this. For example, this is a new graph type, and it needs a new thing in Wolfram model, you know, style, Wolfram Physics Project style data. How do we enter a new thing there?
Max maintains it.
Okay, so Devin, that's for you. Okay.
Yeah.
Okay.
Well,
So
I can make the commit to set replace, and then Max can just update it.
Fine.
Yeah.
So then we just need a color. I made up this darker red color to represent a causal connection graph. Unless you've got a better thought. I think that's a decent color. It's kind of like,
we do use red as an highlighting color, so.
that's true. Well, we want something which kind of reminds us of the causal connection graph. I mean, of the causal graph. It's kind of a super causal graph. It might need a moment with Jeremy to get a color, but okay, this is my preliminary color. Okay. I don't know. Anybody got a thought about this? I mean, this is
it's hard for me to see, but is the edges also different color between those red?
well, the highlighting color. I mean, this is kind of a ripoff of the highlighting color, and it's kind of the wrong thing. I mean, okay. So again, this is for Devin. We need a color Okay. You know what? We could just see if Jeremy could just join us for a moment and get this color. That way we'll
Okay.
have the thing solved.
I'll ask him.
Um, okay, but let's actually write the function here. So the causal connection graph would take is that the right name for it? I think it's a reasonable name. Generate a graph giving the what would you call this in general relativity? I mean, it's like coordinate patches, right? Giving
Well, this is
the
what I'm
causal,
asking. I don't know what it is.
well, you wrote it.
I don't think I did.
You did write it. You wrote it. This is your code. This is using.
Well, where is the function defined? Can I see the code? I don't remember writing it.
You wrote it yesterday, Jonathan.
Maybe you wrote it in your sleep.
What's that?
Maybe he wrote it in his sleep, you know, typing it away.
The
Because you sent me that email saying you thought it was wrong, but without knowing what it's meant to do, I don't.
but you wrote it yesterday. Okay, hold on. Where did I put it in here? This is really kind of bizarre.
I mean, the thing I sent you yesterday, or possibly the day before, was this. Was the thing that produces the complement of the future light cone.
No. There's the thing we did in the live stream. Okay, where did I put it in this file? It's so freaking weird. Oh, here it is. It's in code right at the top. Okay. All right. So
it's getting the
causally
causally connected regions.
Yes.
At a particular time step or not?
No. Remember, it was TITF. Okay, giving.
Yes. Yeah, but there are two different types of causally connected regions at a particular time step or up to a particular time step.
I understand. Okay, so let's write what we say. Given the causally connected regions.
But okay, can I see the function? I really want to
Yes.
understand what it actually does.
Well,
Um,
it's there. It's
so
doing
we
this
have both types. There's causal connection graph and causal connection graph at.
Yes, that's right.
Okay.
Right. So, and the right thing here. So which one is the at referring to, the TI or the TF?
That would be the TI, sorry.
Generate a graph given the relations between causally connected regions in a causal graph. Say that again. It's the TI or the TF?
The TI.
Okay. So
the TF is our finite infinity, so to speak.
Yeah, right. So the default for TF would be the bottom of the causal graph. In fact, if we're giving it, if what we give here, if the causal connection graph is simply taking as an argument the causal graph.
Well, actually, that's a good argument for not just taking the directed graph, because we won't know TF.
Why don't we just go to the bottom of the causal graph?
And what will that tell us?
That's TF.
Not if the space is not globally hyperbolic, as is the case in most of these substitution systems, right? We discovered that you know the layer count doesn't correspond to the time step if the space is not globally hyperbolic.
Fair enough.
So either we give the causal graph and the actual number of time steps.
Yes, or we just give the. I mean, I
We
think
give a
it's
specification.
yeah. I mean, I think it's more flexible to give.
The time step.
Yeah. And then to specify the layer graph, the graph separately.
Right.
Okay. Okay. So okay, so let's look here. So then what we're asking is previous events list, initial events list, previous events list. Oh, that's the at version.
Yeah, that's my hacky way of getting everything on one hypersurface is just take the complement of the vertex lists at t and t-1.
Okay, so what we need to do here, so this is going to take, okay, so first of all, this intersection rule. So one of the notes here is if the future light cone of A contains the future light cone of B, then the resulting graph, then there is a directed edge from A to B in the resulting resulting graph, right?
Right.
Now we never saw if the future light cone of A intersects the future light cone of B, but does not contain it, but neither contains the other. Then there is an undirected edge. Between A and B in the resulting graph. Okay. Okay, so now what we're saying is this thing here generates the causal connection graph. Now you don't need, in principle, I see, you do need the layers, right? You need TI and TF, correct?
Yeah, except this is going to get complicated.
Why?
Because you don't, even if you give integers for TI and TF, you don't know which vertices those correspond to.
What do you mean?
Well, how do you suppose I give you a TI and a directed graph? How do you figure out which vertices lie on that hypersurface? Again, well, if you have hyperbolicity, it's fine, but if you don't, you can't, I think.
I see. So you claim you need an evolution function.
Yeah, or either you need an evolution function or you'd need to specify which actual vertices were in TI and TF. You don't actually need TI and TF.
No, I understand that.
You could just specify the vertices.
Right. Okay, so the possibilities are we can either have VI1, blah, 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 and VF1, blah, blah, blah.
We could support TI-TF, but we'd have to say that we assume hyperbolicity or something.
Yeah, and it's probably going to go wrong most of the time.
Right.
So
yeah.
the alternative.
I'm worried about that.
I think it's not actually that sensible. I think you can always compute it. The alternative is that we give the generator here, instead of a graph here, we give the evolution function What do we need for the evolution function? We need the rules, the initial condition, and we just need a time step, right? I mean, this is going to give, we need the function that generates the causal graph for a given number of steps, right?
Right. Yeah. Right.
And I mean, it's slightly inefficient because we have to go, we'll be recomputing the causal graph, right?
Yeah, yeah. I mean, my current way of doing it is definitely not optimal.
Well, but I think it's a workable thing. Okay, so then, because otherwise you have to have all the tentacles inside to go get the.
Yeah, yeah, right, right.
Okay, then this has TI, TF in it.
If you have the evolution function, you also need the initial condition.
No, you don't. No, what I'm saying for the evolution function is, okay, let's call it CGF. From a causal graph generator.
So you're thinking it's a function where the only argument is the step number.
That's what I'm thinking. Yes.
Okay.
So
Okay.
for example,
Yeah,
it would be
fine.
typically things like and then this is just T there. Well, it's actually a function hash there.
Right.
Right.
Yep, that makes sense to me. By the way, I have another meeting in 1 minute.
So do I.
Okay.
Yeah, so do I. So okay. To be continued. All right. We'll continue this a bit.
Yeah, I need to get my head around exactly what we're trying to plot here, but I agree it's not looking quite right. If that is what it's meant to do.
If what's meant, these things here, I don't think these are quite right.
Yeah, right. But I'm not sure whether that's in the causally connected regions or if that's in connected causal graph, which.
I know. So we can look at it a bit later. Okay. All right. See you guys. See you.
Bye.
Okay. Bye-bye. Bye.